Circular motion problem. We're going to look at number 8 on page 140. So circular motion. Number 8, page 140. It says, a ball on the end of a string is cleverly revolved at a uniform rate in a vertical circle of radius 85 centimeters as shown in figure 533. They give a picture. If its speed is 4.15 meters per second and its mass is 0.3 kilograms, calculate the tension in the string when the ball is A at the top and B at the bottom of its path. Okay, anytime you're dealing with an object moving in a vertical circle, it is very, very helpful to draw a free body diagram of forces on the object at its location. So in A, they're asking about the top of the path. So if you have a ball on a string and it's at the top of its path, gravity is going to be pulling it down. Since it's at the top, the rope at that point in time is pulling downward on it also. So the tension is also downward. So we have these two forces when it's at the top. So now when we do our Newton's second law equation for circles, mv squared over r equals sum of the forces towards the center, we have mv squared over r equals t plus mg. And the reason it's plus is because they're both towards the center of the circle. Okay, and they want to know what's the tension. So we're going to subtract mg from both sides, and that gives us t by itself. And then we can plug our numbers in. The mass is 0.3 kilograms. V is, I lost it, 4.15 meters per second. We have to square that. Divide by the radius is 0.85 meters. And then minus 0.3 kilograms times 9.8 meters per second squared. So we'll punch this all through on the calculator. 0.3 times 4.15 squared divided by 0.85, and then minus 0.3 times 9.8. We have 3.14 meters, 3.14 newtons. So that's when it's at the top. At the bottom, if we drew a picture, gravity is pulling it down, mg, but the tension is pulling it up at the bottom. So they're opposites. When I write out my Newton's second law equation, I get mv squared over r equals t minus mg, because t is in towards the center and mg is away from the center, so it's negative. So when I solve for t, I get mv squared over r plus mg equals t. Now it's the same numbers as the numbers below. It's just being added instead of subtracted. Okay, so I'll do 0.3 times 4.15 squared. No, I did it wrong. 0.3 times 4.15 squared divided by 0.85, and then plus 0.3 times 9.8, and I get 9.02 newtons. So that's the answer to part B. We're going to look at another circular motion problem, and this one is going to be number 12 on page 140. And it says, at what minimum speed must a roller coaster be traveling when upside down at the top of a circle if the passengers are not to fall out? Assume a radius of curvature of 8.6 meters. So we'll write that down. Radius equals 8.6 meters. And that's basically the only information they gave us. So remember, whenever something's moving in a vertical circle, you want to draw a free body diagram of the object when it's at whatever point they're questioning in the problem. So it's at the top. We think about forces on the roller coaster car when it's at the top. Obviously, gravity is going to pull it down with the force mg. And if you think about it, at that point, when the car is upside down, the track is actually pushing down on it, so there's a normal force N. So those are the two forces. So we can say mv squared over r equals the sum of the forces towards the center of the circle. There's two forces towards the center. We have mv squared over r equals n plus mg. Now, the key here is it says at what minimum speed must the roller coaster be traveling when upside down. So at that point, you have to think of it as if the car goes too slow, it's going to fall off the track. It's not going to make it. So the minimum speed would be if the normal force was just greater than 0. So what we're going to do is solve it for n equals 0 and see what we get for v. And then obviously the speed would be anything larger than that speed. So we're going to set n equal to 0 since it's the minimum speed. We have mv squared over r equals mg. The m's cancel. And we're trying to solve this for v. So v squared is equal to gr, or v equals the square root of gr. We can plug our numbers in. 9.8 times r is 8.6. And take the square root. We get 9.18 meters per second. So that's the minimum speed. So the key here was realizing that if it's moving at the minimum speed, the normal force has to be set equal to 0 at that point.